So the big picture for this lesson is nearest neighbor and sorted edges algorithms. So the idea here is, let's say you're starting at point A, and what you want to do is you want to visit every vertex and then return back to your starting point with the shortest distance possible. So in other words, the shortest circuit you can have here. And so one way you can try to find the optimal route is to use what's called nearest neighbor. And what that means is you start at point A, and then you just go to the next nearest point and continue around until you make your circuit. So let's try that out. From A to B, that's the shortest one at 9. Then from B to C. And the next closest one from C is D. And then the next closest one from there is E. And then I've visited everywhere, so I just need to return to A. And you can mark the edges as you go if you would like to. Okay, so that's nearest neighbor. And so what's the total distance? It's 9, 8, 8, 7, and 11. The other method is sorted edges. And that means that you don't worry about where you're starting just now. You just start with the shortest edge. So the shortest edge here is ED. And I'm just going to mark that off. And then, what's the next shortest edge from there? Well, there are 2 8s, so I'm just going to pick one here, and then the other one here. And you just need to be careful when you're doing this not to close out the circuit. So then the next shortest edge is 9, and the next shortest edge is 10. But if I use 10, I'm closing out the circuit for C, D, E, so I'm not going to use 10. The next shortest edge is 11, so I'm going to use that. And that actually does close out the circuit. But that's okay because that includes all the vertices. So it turns out the sorted edges in this case was 9, 8, 8, 7, 11. And the total length for both of these was actually the same. This doesn't always work out this way. Usually one algorithm will provide a shorter distance than the other. So the total here, let's see, 9 plus 8 is 17, plus 8 is 25, plus 7 is 32, plus 11 is 43. So both of these methods provided the same shortest distance for a circuit of 43. But that's how you apply nearest neighbor and sorted edges, and that's the big picture for this lesson.